Reactivating silenced genes in skincare might sound like the plot of a sci-fi wellness thriller, but it's rapidly becoming a legitimate frontier in dermatology. With epigenetic agents now creeping from lab benches into luxury serums, the question isn't just does it work, but also is it safe and should we even be doing this long-term? Because nudging gene expression, even for the sake of better skin, is not exactly trivial business. We're talking about molecular messages that affect how cells behave, replicate, and interact, not just about smoothing a forehead wrinkle or firming your jawline for holiday photos. Let's break this down. What do we mean by gene reactivation in skincare? Many of the genes that regulate youthful skin functions, like collagen production, DNA repair, antioxidant defense, and keratinocyte renewal, become epigenetically silenced as we age. This happens primarily through DNA methylation and histone modification, which shut down gene transcription without altering the DNA itself. Epigenetic agents such as vitamin C, retinoids, peptides, or even newer compounds like sirtuin activators and HDAC inhibitors can potentially reverse the silencing, peeling back the methylation tags or loosening up chromatin to allow genes to wake up again. So far, so good. Reactivate some fibroblasts, reboot collagen synthesis, maybe give those antioxidant genes another shot at defending your cells. But here's where the complexity and risk enters. First, there's the issue of specificity. The genome isn't a buffet where you just pick your favorite genes to reactivate. Many epigenetic modulators are broad-acting. That means while you might be boosting genes tied to regeneration, you could also be nudging ones involved in unwanted cell proliferation, or worse, in pathways related to oncogenesis, cancer formation. DNA methylation is one of the ways the body prevents certain rogue genes from becoming active, particularly those that could lead to uncontrolled growth. So long-term, repeated efforts to broadly demethylate or upregulate genes in skin cells, even with good intentions, might tip a very delicate balance. Second, dose and duration matter. Many of the skincare ingredients being explored for epigenetic effects are relatively safe when used in moderate concentrations for short-term topical application. Think vitamin C or retinoids. Their effects are subtle and gradual. But what about next-generation actives designed specifically to penetrate the nucleus and reprogram gene expression? What happens when someone uses these for decades or combines multiple products with overlapping epigenetic effects? That long-term data doesn't exist yet. And biologically, even small changes in gene regulation over time can produce unexpected effects. There's also the issue of irreversibility. While epigenetic modifications are technically reversible, the full consequences of removing gene silencing aren't always predictable. Cells in aged or sun-damaged skin may have already acquired DNA mutations. If you suddenly reawaken genes in a cell with hidden mutations, perhaps one with a damaged p53 tumor suppressor gene, you could be giving that cell a second wind when it really should be heading for retirement. In the worst-case scenario, this could increase the risk of precancerous changes or abnormal tissue growth. On the ethical side, the line between cosmetic enhancement and biological intervention is blurring. If skincare starts behaving more like low-level gene therapy, should there be regulatory oversight? Should consumers be informed that their anti-aging cream doesn't just moisturize, it modifies gene behavior? What about people who start using these interventions in their 20s, long before signs of aging emerge? We could be heading into territory where beauty becomes less about care and more about molecular engineering, and society hasn't fully grappled with what that means. That said, we're not there yet. Most current products with epigenetic claims rely on nutrients and compounds that influence gene expression indirectly and gently, like resveratrol, retinoids, niacinamide, and vitamin C. These are generally recognized as safe, and their epigenetic influence is mild and part of broader antioxidant or repair functions. The real ethical and biological tightrope walk will begin when targeted gene reactivation technologies, like RNA-guided epigenetic editors or synthetic demethylating agents, start appearing in cosmetic products, and they will, eventually. For now, the best approach is cautious optimism. Epigenetic skincare holds real potential to improve skin health, restore youthful function, and possibly slow biological aging. But it also demands respect. Our genes have been honed over millions of years to turn on and off at the right times for a reason. Tinkering with those controls, even in the name of beauty, should never be done blindly. So yes, Gene reactivation in skincare can be safe, especially when it's done with precision, in moderation, and guided by real science. But the future will demand more rigorous safety testing, long-term studies, transparency from brands, and probably a better understanding from consumers of what they're actually putting on their skin. Because when skincare starts flipping genetic switches, it's no longer just skin deep.